Welcome back to Quadcopter video series. This is episode 4. In the previous episode 3, I explained the airframe of Quadcopter, how to assemble the motors, electronic speed controller and how to solder it. Now in this episode, I will explain about the overview of mission planner, then I will explain the flight controller programming. Next, I will explore into the calibration of flight controller. Thank you for tuning in. Let's start. Headup display. The headup display offers a wide variety of telemetry and monitoring tool that provides real-time data and situational awareness during flight. The head-up display in Mission Planner serves as a graphical interface that provides essential information and real-time data during the operation of quadcopter. The head-up display presents critical flight parameters in a graphical format, allowing user to understand and respond to the quadcopter status. Users receive visual feedback on the quadcopter's orientation, aiding in precise control and navigation. This visual representation enhances situational awareness. Mission Planner's head-up display shows waypoint, mission-specific data, and it offering a visual guide for quadcopter's planned flight path and facilitating mission execution. Telemetry data such as GPS coordinates and sensor reading is continuously updated on the head-up display. Therefore, the head-up display in Mission Planner serves as an energetic tool for operators presenting critical information in a visual inbuilt manner. It enhancing overall control and decision making during quadcopter operation. Quick panel. The quick panel is located on the bottom left side of the mission planner. It is used to monitor the most important flight parameters such as speed, altitude, battery voltage, etc. Getting telemetry data on the head-up display is limited, so user can access a greater number of flight data in the quick panel. You can customize the required parameters in the quick panel. It allows you to see numerous values related to autopilot functionality. Action panel is a convenient feature that provides quick access to commonly used functions and settings. Action panel is designed to streamline the user interface and make it easier to perform essential tasks without having to navigate through multiple menus. Action panel in Mission Planner is a functional component that provides user with a set of tools and commands to interact with quadcopter and execute various actions. A user can access mission related commands in the action panel, it facilitating the planning and execution of special tasks or waypoint during a mission. Real-time telemetry data and monitoring tools are available in Action Panel. It allowing user to track essential flight parameters and make a decision during operations. The Action Panel provides visual indicators and status updates. It offering immediate feedback on the execution of commands, mission progress and overall system health. In case of unexpected situations or emergencies, the action panel may include options for triggering failsafe or initiating return to home protocol for enhanced safety. In Mission Planner, the Message tab is a feature that displays important messages, notifications, and system status update. The message panel will display updates about the status of your drones, including GPS status, sensor calibration status, battery voltage, and communication link with the ground control station. User will receive alert and warning related to flight operations such as low battery warning, GPS signal loss, proximity warning, and any other critical errors or malfunctions which is detected during flight. Telemetry data received from your drone, it includes GPS position, altitude, airspeed, and other sensor reading may also be displayed in the message panel. Information about the communication status between Mission Planner and drone, such as connection status, data link quality, this data also will be displayed on Message tab. If any error or issues occurred during operation, Mission Planner will display relevant error message in the Message tab. In Mission Planner, the Gauge tab is a feature that provides visual representation of key flight parameters and telemetry data in the form of gauges or meters. The Gauge panel displays flight parameters such as altitude, speed, battery voltage, pitch, roll, and yaw orientation in the form of graphical gauge or meters. User can customize the layout of gauges to display the parameters which is most relevant to your user needs. The gauges in the panel are updated in real time, it providing immediate feedback on changes in flight condition and telemetry data during drone operation. The gauge panel may also display diagnostic information about the status of various onboard sensors, systems, and other components. So after a flight, user can review the data recorded in the gauge panel to analyze the drone's performance, identify any issues, or make adjustment as needed for further flight. Status tab. In Mission Planner, the Status tab is a comprehensive overview of current status and health of your drone system, sensor, and other components. The status panel displays overall status of systems such as autopilot, GPS, radio communication, battery voltage, and other sensors health. If any error, warning, or critical alert occurred during operation, Mission Planner will display relevant message in the status panel. The status panel may also provide real-time telemetry data such as GPS position, altitude, airspeed, and other sensor reading. Information about the communication status between Mission Planner and the drone. This data also displayed in system status. In Mission Planner, the Servo Relay panel or tab is a feature that allows user to configure and control servo which is connected to your drone autopilot. Servo relays are used to activate external devices or payload such as camera shutter, payload release mechanism, light, or other auxiliary equipment. The servo relay panel provides option to configure the behavior and setting of servos which is connected to your drone autopilot. The servo panel offers a user-friendly interface for manually controlling and testing servo relay in real time. The servo relay panel provides feedback and monitoring of relay status, indicating whether relay are activated or deactivated. Depending on the capabilities of autopilot hardware and firmware, Mission Planner may offer advanced configuration for servo relay such as configuring pulse width, signal type and failsafe behaviors. Some version of Mission Planner include safety features for servo relay such as failsafe mechanism, restriction to prevent accidental activation of relay during critical flight phase. In Mission Planner, the telemetry log panel is a feature that allows user to analyze telemetry log recorded during drone flight. The telemetry log panel provides access to a list of telemetry log files stored on your computer. This log file contains data recorded during previous flight, including GPS position, altitude, airspeed, battery voltage and other sensor reading. Mission Planner allows user to visualize telemetry log data using graph, chart and table within the telemetry log panel. The telemetry log panel may include tools for flight analysis such as filtering, sorting and data manipulation functions. Mission Planner allows user to playback telemetry log data in real time or at accelerated speed, it allowing user to review the entire flight or specific segment. Allowing user to correlate flight data with mission parameters, waypoints and events. In Mission Planner, the data flash log is a feature that allows user to analyze data flash log recorded by autopilot. These log files contain time-stamped data recorded during flight. It includes sensor reading, GPS position, altitude, airspeed and motor output. Mission Planner allows you to visualize data flash log data using graph, chart and table within the data flash log panel. The data flash log panel may include tools for flight analysis such as filtering, sorting and data manipulation function. Flight data screen with a map is located on the right side of main window. The flight data screen typically displays the real-time position of your drone on a map. This information includes latitude and longitude coordinates, it allowing user to track the drone location. This screen usually provides information about number of satellites detected by the GPS receiver. Additionally, it shows the horizontal dilution of precision, which indicates the accuracy of GPS position. The flight data screen includes a compass heading, indicates the direction in which the drone is oriented relative to magnetic north. The flight data screen displays the exact latitude and longitude coordinates of the drone's current location. In Mission Planner, there are 5 major menus. Flight data. This menu access to the flight data screen which displays real-time telemetry data, sensor reading and system status information during drone operation. It serves as a dashboard for monitoring your drone performance. Flight plan menu. This menu allows user to access tools and features related to mission planning, waypoint navigation. User can create, edit and upload flight plans as well as visualize mission parameters and waypoints. Setup menu. The setup menu contains various configurations and setup options. It includes autopilot hardware and peripherals. So user can adjust setting related to flight mode, radio calibration, sensor calibration and more. Configuration menu. This menu provides additional configuration and mission planner itself. It includes setting related to communication protocol, display options and other customization features. Simulation menu. The simulation menu offers tools for simulating drone flight and testing mission plan in a virtual environment. The help menu contains resources and support options for using mission planner effectively. It includes documentation, tutorial, user guide and a link to online forum or support channels. In the top right corner, there is an option for selecting the port to establish a connection between the autopilot and mission planner. Connection can be done through USB cable, UDP protocol or TCP. Then user should select the correct baud rate. Then user can click connect button. Once the connection is established, it reads all parameters indicating getting parameters. Flight plan window. So go to the flight plan menu at the top of the mission planner window. The flight plan screen in mission planner is a dedicated interface designed for planning and visualizing mission parameters and waypoints. This screen provides a graphical representation of planned mission and it displays waypoints, flight path and any designated action to be executed during quadcopter's mission. User can interactively add, edit and delete waypoints on the flight plan screen, allowing for precision customization of quadcopter intended path. Altitude setting for each waypoint can be adjusted, facilitating control over the quadcopter's elevation at a different point in the mission, also set up in the same menu. Actions such as camera triggering, payload release or other automated tasks can be programmed in the flight plan. User can make real-time adjustment of flight plan, it ensuring adaptability to changing circumstances or mission requirement. Once the flight plan is finalized, user can upload it directly to Quadcopter's flight controller. It ensures the seamless integration and execution during the mission. Mission Planner offers geofencing features on flight plan screen. It allowing user to define virtual boundaries to restrict or control the quadcopter's movement. Therefore, the flight plan screen in Mission Planner serves as a powerful tool for mission planning. Setup menu. Go to Setup menu at the top of Mission Planner's window. Install firmware. Use this option to install or update firmware on your autopilot hardware. Then mandatory hardware. Exploring setting and configuration related to frame selection, IMU calibration, radio calibration, flight modes and failsafe settings. Optional hardware. Access settings and configuration for optional hardware components that can enhance your drone. Optional settings such as camera, gimbal, radio system, motor test, battery voltage and etc. By exploring the setup menu in Mission Planner, user can manage firmware updates, configure mandatory and optional hardware components, and it ensures your drone system is properly configured for operation. In Mission Planner, the configuration menu, you can find various options to configure your drone parameters and settings. Geofence. This option allows you to set up geofence parameter for your drone. Geofencing helps define virtual boundaries for your drone operations. It preventing into flying restricted area or beyond specified limit. So user can configure parameters such as geofence altitude limit and action to take when the geofence is breached. Basic tuning. The basic tuning option provides two essential tuning parameters that affect the flight characteristics and performance of your drone. Extended tuning. In the extended tuning menu, user can find additional tuning parameters for fine-tuning your drone performance and behavior. These parameters may include advanced settings for PID controller, rate limit, filter setting and other parameters. Full parameter tree. The full parameter tree option provides access to the complete parameter tree for your drone autopilot system. This tree structure available all parameters into the category and subcategories. Similar to the full parameter tree, the full parameter list option presents a comprehensive list of parameters related to flight control, navigation, telemetry, hardware configuration and more. So it allowing user to view and modify parameters in a linear list format. By accessing these configuration options in Mission Planner, user can fine-tune your drone performance, set up geofencing for safety and adjust various parameters to meet your specific requirement and preference. So these options provide flexible and control over the drone behavior and operations. In Mission Planner, the simulation feature allows user to simulate drone flight and test mission plan in a virtual environment without the need for physical drone hardware. Mission Planner provides a virtual environment where user can simulate drone flight. This environment may include a simulated terrain, map data and other virtual elements to replicate real world condition. During mission Planner simulates the flight dynamics of drone based on the selection of flight model and parameters. So user can observe how the drone responds to different inputs, maneuvers and other environmental conditions. In Mission Planner, user can create, edit and test flight missions in the simulator environment. This includes setting up waypoints, defining mission parameters, configuring actions and simulating mission execution to verify mission logic and behavior. Simulation mode serves as a valuable tool for training and education. It allowing user to learn and practice drone operations, mission planning and other emergency procedure in a risk-free environment. Next, flight controller programming. In this segment, I will guide you through the essential steps involved in programming the flight control system using Mission Planner Ground Control Station. This process includes upload firmware, frame class and configuration, motor numbering and direction, IMU calibration, compass calibration, radio calibration, ESC calibration, and finally voltage and current sensor calibration. This comprehensive overview will empower user to navigate the flight control programming process effectively using Mission Planner Ground Control Station. Step 1. Upload the firmware. Use a USB cable to establish a connection between autopilot and your computer. Identify and choose the correct COM port to establish a reliable connection between autopilot and computer. In Mission Planner, go to Setup menu, then choose Install Firmware option. Then follow the prompt within the Install Firmware section to select the desired firmware for your autopilot and confirm your selection to initiate the upload process. Upon successful completion of firmware upload, user will listen the confirmation beep. This audible signal indicates that the firmware has been successfully initiated. By following these steps, user will ensure upload the firmware to autopilot, it enhancing the functionality and compatibility with the intended configuration. Step 2. Frame class and type configuration. In Mission Planner, go to Initial Setup section, then navigate to Mandatory Hardware. In the frame type category, choose the correct frame type that aligns with your quadcopter's physical structure and specify the appropriate frame class for your quadcopter and ensure it matches the actual physical layout. Or we can do another method, go to configuration section and locate the full parameter list. Within the parameter list, find and modify the parameter labeled frame underscore class and frame underscore type. By following these steps, you will accurately configure the frame class and type configuration. Then it optimizes the communication between the autopilot and the physical characteristic of your quadcopter. Step 3. Motor numbering and direction. Connect the electronic speed controller to the autopilot's main output pin based on the designated motor numbering. Arrange the motor in the image shown below. It should configure each motor is rotating in the correct direction. For example, motor 3 and motor 4 should rotate clockwise and motor 1 and 2 should rotate counterclockwise. Then next, go to motor test option under optional hardware within the initial setup section. Refer the image to ensure the motor A, B, C and D rotate as indicated. Confirm that each motor corresponding to the designated label and it rotates in the correct direction. Before initiating the motor test, we should ensure all propellers are removed for safety. If motor doesn't turn during the test, gradually raise the throttle percentage until responsiveness is observed. By following these steps, you will effectively conduct a motor test, ensuring that each motor responds appropriately to the designated command. Always prioritize safety by removing propellers before conducting any motor related test. Step 4. IMU Calibration. In Mission Planner, navigate to Setup menu and then Mandatory Hardware. There we should choose Accelerometer Calibration. First we should keep level and then enter the calibration button. Next, rotate the drone left side, then rotate the drone right side. Next, keep the drone nose downwards, then keep the drone upward, and finally keep the nose upside down. So refer the following images on its back position. So follow the visual reference provided to ensure accurate calibration. So observe the calibration successful message indicating that the completion of accelerometer calibration. Note that accelerometer calibration is mandatory in Arducopter for accurate sensor reading and stable flight. By adhering to these steps, you will successfully calibrate the inertial measurement unit and optimize the quadcopter sensor accurately. Step 5. Compass Calibration. Again, go to Setup menu in Mission Planner and navigate to Mandatory Hardware. Then select Compass Calibration. Click the onboard magnetometer calibration and then press the start button to begin the calibration process. When drone is in calibration mode, rotate the copter in full 360 degree and ensure the compass calibration is performed in an environment free from metallic or magnetic field to prevent interference. By following these steps, you will successfully calibrate the compass. This compass is contributing the accurate heading information and enhancing the overall navigational capabilities of the quadcopter. Step 6. Radio Calibration. Go to Initial Setup in Mission Planner and navigate to Mandatory Hardware and then select Radio Calibration. When the drone is in calibration interface, move the transmitter control stick, knob and the switches to their respective limit. Before initiating the radio calibration, be ensure that all propellers are removed for safety. Actuate each control elements on the transmitter, move to its full range of motion to allow the autopilot to register the full spectrum of input. Always prioritize safety by removing the propeller before conducting any calibration. By following these steps, you will accurately calibrate the radio inputs and it ensures that the autopilot recognizes the full range of commands from the transmitter. Step 7. ESC Calibration. Again in Mission Planner, go to Setup menu and then navigate to Mandatory Hardware section. Then choose ESC Calibration. So inside the ESC calibration window, follow the instruction provided to start calibration. So first remove propellers from the quadcopter, then click on the ESC calibration button to start the calibration process. Then disconnect USB and battery connection. Then after 3 seconds, plug in the battery. Then push the safety button to initiate the calibration. After that, ESC should emit a series of beeps. It indicates successful calibration. Then finally, restart the flight controller. Always ensure that the radio calibration is completed before initiating ESC calibration. By carefully following these steps, you will effectively calibrate the electronic speed controller, it ensuring synchronized and accurate motor response for optimal flight performance. Step 8. Voltage and current sensor calibration. Go to Setup menu and navigate to Optional Hardware, then select Battery Monitor. Choose the current sensor type and hardware version from the available options. Also update the accurate battery capacity information. If utilizing a third-party sensors, manually enter the voltage divider value as it is required. Finally, reboot the autopilot to ensure proper synchronization and accurate voltage reading in Mission Planner. By following these steps, you will effectively configure the voltage and current sensor setting, it providing essential information for monitoring and managing the battery information during flight.